Digital twin for multi-real-time co-authoring and collaborative workflows in AEC. My name is Hector Camp, CEO of IQ, providers of consulting services related to integrating people, product, and process, and managing information for the building lifecycle. My co-presenter, Mansu Kim, mechanical engineer with Imparia, has 15 years of extensive experience in developing world-class buildings using CATIA. Today he's working as an automation architect for Paria. I will be presenting our collaborative aspects of our presentation, and Mansu will be sharing his automation experience utilizing EKL. This is our story. In 2000, I went on an architectural pilgrimage. Top of my list was to go see the Guggenheim in Bilbao, which was developed by Frank Gehry and it happened to be created on the CATIA V4 platform. When me and my friends got to Bilbao and exited the train, we were right next to the riverfront. So intuitively, we began to walk on the river, and along the way, we came across a pedestrian bridge, the Zibizuri Bridge. To put the story to put the story of collaboration in perspective, I would like to take you on a journey of the project. So here we are in Miami, my hometown. This is Miami. This is where I live. Okay. And this is a beautiful part of Miami here. This is Key Biscayne, Brickell Key over here. This is the Brickell area. Here you're looking at downtown Miami. And if I just kind of pan around a little bit, this is where I am. This is the courthouse building, and IQ is located on the ninth floor of this building. Okay. So here in Miami, in this city, is where I began my part of this process. Now let's go a little bit over. So from here, I am collaborating with my friend Mansu Kim, who lives in South. And this urban density that you're seeing here, this is the city of South. Somewhere in this city is Mansu Kim. I've actually never met Mansu Kim. I only know him virtually. He only knows me virtually. And together we coexist in this virtual world, and we have a common platform between us that's bringing us together. Now, the project that we're working on collectively is in neither cities, right? It actually happens to be in the city of Bilbao. Now remember, I actually went to Bilbao specifically because I was interested in going to see the Guggenheim. Okay, and here you can see the Guggenheim. I'm just gonna close that out here. I always say I think this is the building that changed the history of architecture and revolutionized the building industry forever in unimaginable ways, right? This project brought me from Miami all the way here to Bilbao to understand this project. Now, this is the reason why I was in Bilbao. But along the way, I was walking on the river, and here on the river is the Zibizuri Bridge. 20 years ago, and today is 2020, and I was there in 2000, so really it's been 20 years. This bridge inspired me, and today we've recreated it using CATIA. This is what I see. And I was really amazed by the elegance of this design. The cantilever that catches this parabolic arch it's a beautiful, elegant work of architecture and engineering. Just put maybe one more perspective here. Just since I can't afford to take everyone to Bilbao to go see this bridge, I can kind of show you this experience of what it looks like. And Guggenheim is further down the street this way. You can kind of see parts, a little bit of it here. But this tension bridge um, was extremely inspiring to me when I was there. Alright, so Santiago Calatrava is essentially a prolific engineer. Some of his noteworthy projects include the Milwaukee Museum of Art, the Athens Olympic Stadium, the Turning Torso, and the World Trade Center station, which is also referred to as the PATH train station. Specifically, the project that we're talking about here, the Zubizuri Bridge, Mansu and I looked at thousands of images related to the Zubizuri Bridge in Bilbao. Here you can see a cross-sampling of cross-sections of those images that were instrumental in informing us our understanding of the bridge. Through research, I was able to identify an elevation of the bridge. This elevation was instrumental in helping us understand the angle of the parabolic arch. Moreover, I was able to find a front elevation of the bridge showing the parabolic arch itself and its relationship to the river banks. So we asked the question, can we recreate the bridge in 3D in real time with a globally distributed team? Is a technology really here to do this today? So we began to collaborate. We implemented two solutions on the 3D Experience platform. First, we created a shared collaborative space. Second, we created a 3D swim community. I like to think of the swim community as social media meeting project development. In this image, you can see the icon for the collaborative space, 3D space, in the 3D Experience platform. In the right, you see a list of collaborative spaces. The Space Digital Twin Global was created to work with Mansu Kim. For this experiment of multinational collaboration, Mansu was invited to the space and was given digital rights of leader and was assigned all the appropriate licensing to author the model. Throughout the life cycle of the project, we used the 3D swim community Zibizuri to communicate back and forth with pictures, media, ideas, questions related to the project in an informal way. Let's open the 3D Experience platform and do a search for Zibizuri Bridge and use W6 tagging to filter. In this case, we're going to filter by user and we're going to filter by collaborative space. So for example, if I go to Chrome, I'm going to find a platform I want to log in with my secret password. And there you have it. I'm logged into the platform. So this is the new updated version of Category 6 3D Experience Platform 2021 or 2020. So if we come here to the compass, you're going to see the new expanded roles. I'm going to compress my roles. I'm going to close my apps, and I'm going to go ahead and expand on my favorite app, which in this case is Building 3D Design would be my app of choice that I'm going to open at this time. Okay, now that Kitty has opened, I'd like to point out that we're working in a collaborative space, Digital Twin Global. You can see that the one that I'm working with has a blue icon next to it, and that's effectively where all my multinational projects were globally collaborating with Mansu Kim, in this case, are all being saved. This was a shared collaborative space that I created and invited Mansu Kim to be my co-author with me on. Okay, so to begin the process, I'm going to run a search for the Zibizuri Bridge. I'll use a previous search, in this case a ZUB, because I don't remember how to spell Zibizuri. So whatever I know, I'm going to go ahead and put it in there. I think it's really critical to understand that you need to know where your information is and you need different strategies to help you find that information. So here if we look under the source, you're going to see that I have communities. I got Google Drive. I have multiple databases connected here. But the one I'm looking for is on collaborative spaces. Okay, and specifically, we're looking at one specific collaborative space, which is the Digital Twin Global that I created for this multinational experiment. So I'm going to go ahead and select. I'm going to add Digital Twin as a filter, and you can see here at the top where it says which filters are being applied and selected. You can see them listed here. Now, I can then expand on owner, which is kind of nice because here you can see, in this case, things that have the word Sibizuri in it. There's about 17 documents from Monsoon and about 9 from me. So since I specifically want to look at the ones I'm working on that are assigned to me, I'm going to filter by my name. And this is going to give me the elements that I've been essentially working on. So once I'm ready, I can find the object I want. The Zibizori looks promising, and I'm going to go ahead and click open. And this is actually a model that we're seeing here. This is actually a live working model. Let me just hide this here. I'm still in the process of developing the project, but this is a work in progress. You can see the detailing of them here on the ramp and how we're developing the bridge and the connections to it. And you can see the center section that was created by collectively created by myself and Mansu Kim working together multinationally to develop this. You can also change the environment, for example. I say with a pure white. Let's do a mirror white. A little bit high, so it's not going to show, but you get a sense of where we're going with this. And I always like to look at it in perspective. Let's say 35. And if we go to under view, we can customize our settings. And I'm going to get rid of no wires, no access, no points. They're going to give me a cleaner view of the model. You can see how she's coming along. So this has been a beautiful study that I've been able to engage with my friend Mansu Kim to develop this project. Nothing helps you really have an appreciation for other people's work than to recreate the work of a master. So hats off to Calatrava. We love you, man. I think this is fantastic. So more to come through the presentation. I want to talk a little bit about the proc structure for a moment. While it may not be obvious at first, the proc structure plays a very big role in managing information and allows us to work at a very granular level. Don't think of the model as just one big model. Think of it as as an assembly with some assemblies working together to make up the whole. We developed the bridge as an assembly made up of three sub-assemblies: the bridge, the north bank, and the south bank. Another very important component Another very important component of the model is a part that we use as a controlling mechanism called the driver. The driver part contains all the drivers that are common to the project, such as points, lines, and planes. These reference elements are used to inform the geometry of the other subassemblies. The other subassemblies are linked to the shared asset, meaning if those shared assets were to change, those changes would be driven throughout the other subassemblies that depend on them. Another interesting component of this collaboration workflow was our use of publication. Publication allows us to officially define what are the common elements that are allowed to be shared across the assemblies. This way, we can control what reference elements everyone is using throughout the project, and it's clear what the common drivers are. This in particular is very important when you're working on a complex assembly. Ownership. Ownership is one of the biggest topics that comes up for us when we're talking to clients about global collaboration and co-authoring of anything. This this is where collaborative lifecycle management comes into play. In short, the platform is keeping track of who owns what throughout the entire project development cycle. In a fragmented world, people duplicate information and effort all the time, mostly because they cannot leverage what has already been created by others. But with 3D XP, you can archive your model at any stage of development and transfer ownership rights to a new author who can then leverage your model for further development throughout the product development phase. The intellectual property of the model can shift back and forth with owners as the project evolves as a progression. In instance, you can say that the Experience platform eliminates the handoff and rework that is common in a fragmented product or project development process. And effectively, that's what we did. Um, I made up many of the drivers for the model and I transferred the ownership to Matsu. In this image, using collaborative lifecycle function, you can see that the ownership rights for the design driver here are owned by HCamps, which is me in this case. But now let's take a look at the bridge. You can see that the bridge ownership has been transferred to Cave Matsu. The point is that the project tree, also referred to here as a product structure, allows us to manage intellectual property. In addition, it allows you to work on different parts of the model at different times and in different locations. If you have concerns that someone could change your design, you can log the branch that you're working on, which will prevent anyone making changes to your model. If someone did try to make a change to the model, but they didn't have the editing rights over those changes, it would basically not be saved to the database. Okay, so I think this is really critical. It's one of the main concerns that I think people have when you talk about these collaborative ideas. We will now look at the model. Before we start, I'd like for you to look at the products tree on the left. Notice that I used the elevations, showed you the elevations I showed you earlier. Notice I use these elevations in the model using a tool called Sketch Tracer to position them into the model. I also included an image from Google Earth. Please note that the Collaborative Space Digital Twin is also at the top of the upper right-hand corner of the modeling environment. Mansu is going to take us through a presentation on automation using the EKL programming language and knowledge aware.
Hello, my name is Mansu Kim and I work for Imperaria. First, I would like to thank all the COE officials and actors for inviting me to COE. Also, I would like to thank to attendants for their time. To start, let me introduce myself briefly. I have been using CATIA for about 15 years and I am currently working as a virtual automation architecture in charge of building a template related to building design and construction manufacturing using CATIA. Due to the nature of CATIA's utilizations, I have been working for ways to enhance the strengths of CATIA's parametric modeling by focusing on the free-form shape building project. And I am interested in automations modeling using EKL languages. From this perspective, what I am going to introduce today is an automated modeling methodology using EKL language. Let me introduce you to the video and workflow for the automations modeling methodology. To take advantage of this automated modeling method, you can produce to the template designer role and the architectural detail design role. Building 3D design app and the engineering rules recapture app were utilized as a major apps. Also, this example is a Federations Bridge in Bilbao, Spain, called Jubijuri, designed by Santiago Calabatra. Agenda are as follows. Then, let me introduce EKL automation. First, we have prepared modeling automations video that we built. After setting the number of a grid, you can see that the class template is automatically created by learning the knowledge pattern. There are some objects like a Boolean and transom that can be used in conjunction with the grid that was created this time, which can also be automated in a similar way to template the class. In fact, almost every part of this bridge that you are looking at has been built using this method of automations, like safety layers, substructures, and wires at the top. When building a template, we consider LOD level, which starts with a right and simple shapes, and we can check the overall shape and generally upgrade the LOD level. This is how grills and seat panel members are automatically created. As an advantage of creating automations modeling, we can always update and upgrade our template. For example, if you needed to change the section design of the safety layer, as you can see in this video, you can update only one template of the safety layer. We are going to build the rest. Now, we are changing the size of the grid by modeling the grid. Next, I will explain that it is divided into the stage, which is reference geometry, input creations, template creations, and output creations. Let us look at each element. First, we start by preparing a reference. We can refer to the geometry as defined in the other part file or the higher geometry set in this step. That is by linking mass modeling or geometry made in the skeleton sections, we can link them to the design of the previous stage. The second section is the input creations to apply template. This part can also be automated internally. So it can be automated using datum generation functions provided by small UDF or power copy by EKL engines. This can be used as an input value for the next automations utilizing list. This example of using the create or modify datum syntax is an example of a loop syntax. Declare the parameters you want to use first and calculate the distance and the equal protections value of the curve so that you can know the locations of each point. Finally, we completed the loop using a when syntax. Point create in this way, we will be including in this specified list. You can also create an ISO curve in a similar way. You can use them method to create V point, H point, V curves, and H curves. Next is the template creation sections. This is the step to create the result using the pre-created input value. Because automation's modeling concept can be modeled repeatedly, they can be initially made into simple, right shape, and finally the detail can be upgraded. For example, you can integrate with a template such as adding attribute, such as a 3D tag operations, or creating a grid view that can be linked to the further drawings. We use Power Copy for this example. Finally, this is the step to create an output using ETL automations. At this stage, uh, the input value required by the template are replaced in the input list. Let us take a quick look at ETL automations. Declare the parameters you want to use. It also uses when syntax can create a phrase that responds to input curves. Finally, when we had to create alpha geometry repeatedly due to design changes, we used Vivy script to delete previous created objects. If you run this Vivy script on the first line of the knowledge patterns, the previous output object will be deleted whenever the knowledge pattern is executed. I will end my presentation here. If you have any questions about more details, please email me anytime and I will answer them sincerely. Thank you.
I hope you enjoyed that. Now, 3DXP Cloud lets us collaborate anytime, anywhere, on any device. Despite being geographically dispersed all over the world, I'd like to talk a little bit about the anatomy of global collaboration. So from this experience, you need a couple components here. One, you need a fast, globally available internet, of course. You also need a common platform. In this case, of course, we're using the 3Experience platform as a common platform. You need an integrated platform. So think about the different roles and disciplines and people who need to come together to work on a project. So you need an integrated platform across domains of knowledge, across disciplines, this sort of thing. A shared common database. So that database, you need a common database. And that database can't live on your computer. It has to live in the cloud because without it being in the cloud, um, you might be able to synchronize from a local server to the cloud server, but you need a cloud server to manage the data, especially when you're going across a global geographical area. Okay. Let's see. You need an IP management server. So the server that's in the cloud, in addition to just managing the files, is also managing the intellectual property, who owns it, and those contributions. And that's why most other softwares really can't do this because they don't have and they go between infrastructure that it's managing those relationships when data is going to the cloud. You need you need a collaborative application that's been built specifically for the purpose of collaborating. In addition to collaborative software technology, you need collaborative workflows. So the technology and your processes have to be kind of built around actually working, managing information, transferring ownership, all these things. Your workflows have to be collaborative in nature. You need open lines of communication. So when you're working on a complex project, the communication is critical. Keep in mind, I don't speak Korean. I speak Spanish and I speak English, and Mansu speaks Korean and he speaks English. We used the 3Experience platform to communicate among each other on a common platform, on a common language. In this case, we use English, and we were able to work together, and we were able to get this model built. Okay, and lastly, the human component, you need trust. All right. So at this point, there's something else that I probably need to say, and I can probably give a whole entire presentation on just this topic by itself. So of course we have COVID-19. But originally, my presentation has always been about global collaboration because the building industry is globalizing. Our projects could be anywhere in the world, as well as their contributors. But today, thanks to the ongoing pandemic, we have a new driver that's shedding light on the topic of remote distributed workforce and business continuity. Please keep in mind that our collaborative efforts were ongoing during the pandemic crisis. Mansu and I were working together regardless of all the global disruptions that were ongoing. We had zero impact on our ability to work together. Anytime, anywhere, on any device. We are proud that we were able to accomplish this today on the 3Experience platform in the AEC industry. That concludes our session on digital twin for multinational real-time co-authoring and collaborative workflows in AEC. Thank you again for joining. If